2.6. 2.6 talks about composite functions. Okay. Here's our objectives for 2.6. First of all, find the domain of a function. Second of all, combine functions using the algebra of functions specifying the domain. So once we get the first part, the second part should be okay. Number 3, form composite functions. Number 4, determine domains for composite functions. And number 5, write functions as compositions. Okay? So first of all, finding domain of functions is something we've talked about several times before. Got it? Finding domain is something we've talked about several times before, but just to remember, for example, if I say this particular function is x squared minus 7x, what's the domain of this function? Is there anything x is not allowed to be? No. Okay, so our domain is either going to be all real numbers or negative infinity to positive infinity. Remember talking about something like that? Yes. We're just looking to see, is there something x is not allowed to be? In this specific function, there's nothing x is not allowed to be, so it's all real numbers is our domain. Okay? What about in this particular function? Is there anything x is not allowed to be? Why can it not be negative 5? The denominator would be 0. We can't do that. Okay? So our domain would be all real numbers except for negative 5 is how we'd write it that way. But remember, the other way in interval notation, we would write from negative infinity to negative 5, and then from negative 5 to positive infinity. But I've not included negative 5 anywhere because it's a parenthesis here and a parenthesis there. Either way. I think most of the time on the computer and in the book, it's written in interval notation. But I want you to be aware of both ways, because just looking at it right now, it is written in inequality notation right here at least once or twice that I can see. Okay. What about that? What about negative 4? Well, it seems like what you did is take what is underneath the root sign and set it equal to 0. It's kind of what she did a second ago. She took the denominator and set it equal to 0, right? So if we take what's inside and set it equal to 0, we get x equals negative 4. So we have to think about what this function actually looks like, right? This is a square root function, so the parent function looks like that, right? So the domain of the parent function is everything greater than 0, right? So think about the fact that if we have negative 4 right here, what's happening around the negative 4? Well, it's either not happening or it's continuing, right? Because it's not going to go all the way to the left because there's a beginning point. And we know this is a positive function, so it is starting somewhere and going off to the right. Okay? So our domain for this function is going to be x is greater than or equal to negative 4. Negative 4 is what we found when we set this equal to 0, and we know it has to be everything greater than that number because that's where this transformations is happening. The transformations here is happening. Okay? So in inequality notation, that's what it looks like in inequality notation. In interval notation, it's just going to look like this from negative 4 to infinity. One more, and then we'll talk about a little bit more in general. 1 over x squared minus 2x minus 3. Well, what we said we do in situations like this is we set either what's inside the radical or what's in the denominator equal to 0, right? Well, if I set that equal to 0, we could do those in our head, right? Most of us could do those in our head. Here, I've got to factor that, don't I? Or use the quadratic formula to solve it. But factoring would be a whole lot easier. X minus 3, x plus 1. Did you get that? So x equals 3 and x equals negative 1. So what kind of domain are we going to have in a situation like that? Isn't it going to be everything but those numbers? Because think about what that looks like. That's a rational function, right? It's not going to look exactly like a rational function just because it's got a squared in there, but there's still a general idea. So our domain is all reals, but x is not equal to negative 1 or 3. So in interval notation, negative infinity to negative 1, and then again at negative 1 to 3, and then again from 3 to infinity. What did she do? Oh no. Oh no. Oh no. Okay, let's focus a little bit. Yeah, I'll have to cut that part of the video. Great. Yeah. So find the domain of a function. How do you feel about finding the domain of a function? Okay, if it's linear or quadratic, any of the basic functions that we talked about at the beginning, you already know what those domains are. Any other time, if it's a rational function, if it's a square root function, anything like that, we need to figure out what x is not allowed to be, and sometimes that means setting things equal to 0. Okay? So finding the domain of a function we're good at, right? Combining functions. Well, combining functions is definitely something we did in Algebra 2. And right now, as I say it, you may not remember it, but when I start showing you, I think you will. Okay? You ready? Okay. I'm going to say f of x equals 2x. And g of x equals x minus 1. So the first thing I want you to find is f plus g of x. So what is it asking me to do? Yeah, add them together. Okay? Well, f is 2x, g is x minus 1, and if I'm adding them together, what do I get? 3x minus 1, done. What's the domain of that function, by the way? It's a line, right? So it's all real numbers? Or negative infinity to positive infinity? Whoa. Now you have me doing it. What about f minus g of x? Well, f of x is 2x minus g of x, which is x minus 1. So that's going to be 2x minus x plus 1. Because I'm subtracting every part of g of x, right? So I'm going to get x plus 1. If I take a linear function and add it to a linear function, does it make sense that I would get a linear function? If I take a linear function and subtract a linear function, does it make sense that I would get a linear function? What's the domain of this function, this new function right here? All real numbers, or negative infinity to positive infinity. So what's next? We did f plus g, f minus g, f times g, 2x times x minus 1, 2x squared minus 2x. What kind of function is that? Quadratic? What's the domain of a quadratic function? Yeah, all real numbers. And the last one? Divide. F divided by g of x. Well, f is 2x divided by g of x is x minus 1. Okay, done. That's all we can do. What's the domain? Well, is the denominator allowed to equal 0? So it is all real numbers, but x is not allowed to equal what? 1. So it goes from negative infinity to 1, and then again from 1 to positive infinity.
So that's always a union?
It's a union, It's always a union, because it's one part and the other part. Any questions about that?
So what would the question look like after this?
It'll say f of x equals 2x, g of x equals x minus 1, find f plus g of x.
So then we use the adding one?
Mm-hmm. Yeah.
What word like that?
No, you're fine. Let me see if I can find one real quick that makes sense. The quick one I can find for composite functions is says, suppose that your local computer store is having a sale. The models that are on sale cost either $300 less than the original price or 85% of the original price. So it's either x minus 300 or 0.85 times x. So at the store, you're going to bargain with the salesperson. And eventually she makes an offer you can't refuse. It will be the sale price. The sale price will be 85% of the regular price, followed by a $300 reduction. So it's both 85% and minus 300. It's a steal. I mean, yeah, completely unreasonable. But that's the word problem I could find real quick in the book that talked about composition of functions. Okay, so, but
That's just like adding and subtracting.
yeah. No, it's not. That's not multiplying. I'm trying to see if I can find one real quick that's multiplying. And I think I said composition of functions. I just meant combining functions right there, not composition. And I don't see one real quick that does that, that talks about that. I can probably find one for you in a minute, if that's all right. Okay. Because here's the deal. The next thing on our agenda for our objectives is to form composite functions. Okay? Composition of functions is different than combining functions. Okay? Composition of functions has a very specific goal in mind, and we actually don't get to that goal today, but we start with that in mind today. Okay? Composition of functions is when I tell you f of x equals 2x, just like we had a second ago, and g of x equals x minus 1, just like we had a second ago, but this time we're finding f of g of x. That's not the same thing as f times g of x. We're finding f of g of x. Well, what I want you to remember is that this used to say f of x, right? That means anytime there's an x, what do we want to put in there? A g of x. So I'm going to start writing f, but instead of writing x, I'm going to write g of x. Does that make sense? Well, except I know what g of x is. I know g of x is x minus 1. Okay? So I get 2x minus 2. So f of g of x is 2x minus 2. I've combined them in a way. And not, well, it's a composite function. It's not a combination of functions. It's a composite functions. A composite functions? Okay, we'll go with it. All right? So the other thing I want you to realize is this is not the only way this is written. And in fact, it's written both ways in the notes that I have, so I want to make sure you know both ways. Okay? It's either written like this or written like this. So a lot of times we actually call this fog. And we did this a little bit in Algebra 2. It wasn't a really big focus because it's not really a big part of our TEKS. Okay, we did this a little bit. And if you took pre-cal before this, you definitely did it in pre-cal. Okay? But see, the thing about it is, if I think about this for me real quick. If I take F plus G as compared to G plus F, is that going to be a whole lot different? Plus, it's not going to be different at all. Times, it's not going to be different at all. Subtraction, some signs will change. Division, the 2x will be on the bottom instead. But composition of functions is a little bit different. Okay? Because this is what f of g of x is. But what if we do g of f of x? That means I start with g. I start writing g, but instead of writing x, I write f of x. So I have f of x minus 1, but I know f of x is 2x, so I get 2x minus 1. Okay? Now, like I said, composition of functions has a really good purpose, has a goal. You don't find that out today. You'll find that out, I think, tomorrow or the next day. Tomorrow. Okay? But today I have to make sure you understand how to do composition of functions so that tomorrow we can apply it. Does that make sense? Okay, so are they all this easy? No, of course not, right? So let me do one that's a little bit more difficult for you. F of x equals x squared minus 6x plus 5. And g of x equals x plus 2. So first of all, let's do f of g of x, or fog. So I start writing f, but anytime there's an x, what do I write instead? I could write x plus 2. Now some of you need me to write g of x first, except that's a minus. But some of you can skip that step. Okay? Well, I know g of x is x plus 2, so I have x plus 2 squared minus 6 times x plus 2, and then plus 5. Well, x plus 2 is x squared plus 4x plus 4. Remember, because I have to do x plus 2 times x plus 2. Remember that? And then I have minus 6x minus 12, and then plus 5. So at this point, all it is a matter of just simplifying your like terms, right? So I have an x squared. I have a 4x and a negative 6x, so minus 2x. And then I have a 4 and a negative 12 and a positive 5. So negative 3. So that's f of g of x. What is GOF? What is g of f of x? Well, I start writing g. Anywhere there's a g, I put in an f of x. Well, f of x is x squared minus 6x plus 5 plus 2. So that one's way easier, isn't it? X squared minus 6x plus 7. You understand composition of functions? Does that make sense? Okay, so 3 was form composition of functions. 4 is determine domains for composite functions. Well, let's look back at these two that we just did. Okay, if I'm looking for my domain in f of g of x here, that's just a line. What's the domain of a line? All real numbers. I mean, if you're comfortable with the first couple domains we did, you're comfortable with these, right? Because it's the same kind of idea. What shape is this? It's a line. So all real, negative to positive. What shape is this? It's a quadratic parabola, so my domain is all real numbers. What's this? Quadratic, so my domain is all real numbers. So the times that it's going to get weird is when it's not a parabola or a line, and you just got to remember back to what your parent functions look like so you know what their domains look like. Okay? write functions as compositions. Well, that's what we were just doing. Okay, writing functions as compositions. And really what that was starting with the g of x and then putting in the function. Okay. Another way we can look at it is like this. If I tell you what h of x is the cube root of x squared plus 1. Can I write this function as an f of x and a g of x? Well, let's think about h. Okay, h takes x squared plus 1 and takes the cube root of it, right? So we could write h as a composition of functions where we're taking the cube root of x squared plus 1, which means I would take f of x and make that a cube root. What would g of x be then? What am I taking the cube root of? X squared plus 1. So if I did the composition of functions f of g of x, I would put g inside where x is, and I would get h. Does that make sense? So on all of these, it's saying take these two functions and find its composition. Writing functions as compositions is taking this one and trying to separate it out into two parts. Now, please understand, it's not going to be something like this. It's going to be something like this. That is pretty logical to see that if I take the cube root of the thing inside, if I make this one the cube root and I make this the thing inside, to go find the composition f of g of x, I will get h of x. Does that make sense? Now, could I do that for g of f of x also? Well, that wouldn't be the same thing anymore, would it? Okay, so we're mostly just talking about one directional composition of functions. Do this one for me real quick just to make sure you understand. The square root of x squared plus 5. What would f of x be and what would g of x be if I want to do FOG, f of g of x, and get that? F of x would just be square root of x, and g of x would just be x squared plus 5. Any questions about that? Okay, so let's look back at our objectives just to make sure. We found the domain of a function. We combined functions using adding, subtracting, multiplying, dividing. We've also formed composition of functions that way. We determined domains for composite functions, and then we were able to write functions as compositions. You good? Okay. That's 2.6.